Hello and welcome to this IChemE Global Awards 2021 webinar. My name is Matt Stalker and I am your host for today's presentations. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely considered as the world's most prestigious chemical engineering awards. Over the last 2 weeks, we've presented 15 awards and now we have reached our top prize, the Outstanding Achievement in Chemical and Process Engineering Award, sponsored by the chemical engineer. This award is quite simply the best of the best. All our team award winners from this year are in contention, and in just a moment I'll hand over to IChemE President Jane Cutler to announce our winner. Before I do that, let's recap our 2021 award winners. We have TeQ Water, winner of the Biochemical Engineering Award. Chemical Processing Services, winner of the Business Startup Award. Wood, winner of the Diversity and Inclusion Award. Pannonia Bio, Energy Integration and Pillar Blowers and Compressors, winners of the Energy Award. Corteva Agriscience, winner of the Industry Project Award. Zhejiang Haimata New Materials, Ningbo University and UCL, winners of the Innovative Product Award. Saudi Aramco, winners of the Oil and Gas and Sustainability Awards. Micropore Technologies, winner of the Pharma Award. Petronas Digital and Malaysia LNG, winners of the Process Automation and Digitalization Award. GSK R&D, winner of the Process Safety Award. ADNOC and Microsilicon, winners of the Research Project Award. And finally, Imperial College London, UCL and the University of Oxford, winners of the Team Award. So they are our contenders, all of them already winners this year, but only one of them can lift our top prize. And for that, I'll hand over to the President of the Institution of Chemical Engineers, Jane Cutler.
Thank you very much for the introduction, Matt. I'm delighted to be joining you all today, and I'm especially pleased to have the great honour of announcing the winner of the top prize in IChemE's Global Awards programme, the Outstanding Achievement in Chemical and Process Engineering Award, which I'll get onto very shortly. The IChemE Global Awards bring together chemical and process engineers from around the world to recognise their peers' significant achievements in tackling global challenges and developing solutions that will have real impact on all our futures. This has been perfectly demonstrated by the finalist presentations that we've shared over the last 2 weeks. Although there can be only one overall winner, our expert panel of judges have already selected you all as winners in your own categories, in what I understand was a highly competitive field. By being on the shortlist today, the judges have already acknowledged your excellence and you should all take real pride in your achievements. I would like to congratulate you all on the dedication, commitment and passion that you have shown to our profession. Chemical engineering is a profession that I'm certainly proud to be part of, and I very much enjoy learning about such excellence in our field. The range of achievements we are here to celebrate covers such a fabulous range of projects, innovations, personal accomplishments, and team successes, which address a vast array of issues, whether they be environmental, social, or economic. All of us today already know chemical engineering really does matter. Chemical engineers are acutely well equipped to deal with the challenges facing society, particularly those around climate change and supporting the UN Sustainable Development Goals. So I'm particularly pleased to see that one of the awards in the programme is for sustainability. Chemical engineers are ideally placed to address these global challenges that are faced by communities in every country, in every part of the world. Your work is contributing significantly to this, and you should be very proud of it. Just before I announce the winner, I'd like to thank the volunteer judging panel, who using their vast experience and expertise have spent a vast amount of time reviewing each finalist submission. So now to the matter in hand. the moment you've been waiting for, no drum roll on the video. It's time for me to announce the winner. The winner of the IChemE 2021 Outstanding Achievement in Chemical Engineering and Process Engineering Award is Cleantech Water. Many congratulations to Cleantech Water and everyone associated with their winning entry. Your project, Innovative Biological Technology for Nitrogen Removal, provides a fundamental shift in how bacteria are applied in water treatment. Your innovative technology can be employed in the treatment of wastewater to remove nitrogen to very low concentrations, which both reduces the negative impact of nitrogen for human health and wildlife and our waterways, but is also a key enabler for recycled water use. Compared to current methods to address excess levels of nitrogen, your technology is more effective and more cost efficient, meaning the future implications of this technology for global wastewater treatment and for environment is really significant. In talking to the judges, I understand they were particularly impressed by the engineering excellence demonstrated in your approach, which is to be commended. On behalf of everyone at IChemE, I would like to thank you all for your efforts to advance chemical engineering for the benefit of society. And I wish you all the very best in your future endeavours. Well done to all of you. And now, before I hand back to Matt, let's find out more about our winning entry.
So I'm going to introduce Cleantech Water's development in the nitrogen removal and biological treatment sector over the past few years. So to set the scene, elevated nitrate levels are a major issue around the world. Issues often arise from municipal wastewater treatment, as well as mining or industrial wastewater. Discharging nitrate contaminated water into natural water bodies can lead to eutrophication as a contributing factor to algal blooms that can lead to major fish kill events, which can impact waterways and significantly impact communities that depend on those healthy aquacultures. Many countries, including China, are introducing stricter nutrient discharge limits to limit environmental impact. Potable water is another sector which is negatively impacted by nitrate pollution. Nitrate contamination of groundwater is a major global health issue and can lead to conditions such as blue baby syndrome and various forms of cancer. Conventional bacterial treatments such as CAS, MBR, BNR can struggle to reach new limits of less than 1 ppm, which are being enforced across the world. And whilst our own batch ion exchange process can reach those, they do produce very large volumes of concentrated waste that does need disposal. So Cleantech Water's BioCleanse and binex technologies can be implemented in a various number of ways to improve the health of people and the aquatic environment. BioCleanse is a biological technology in which microorganisms are encapsulated in a PVA gel carrier, which maximizes the diffusion rate and protects bacteria from harsh saline conditions, enabling consistently high nitrification and denitrification activity. Innovative coupling of this with our proprietary continuous ion exchange technology, which we call CIF, forms our binex product, which is a patent-pending integrated system which allows for consistent nitrate removal to sub 1 ppm levels in a system which has a very small footprint, low capital and operating costs, and produces a lot less waste than conventional nitrate treatment methods. Continuous ion exchange is used first in this process to intensify the nitrate into a high concentration, and then it's reduced by the BioCleanse to basically produce a nitrogen gas as the final product. This has a number of benefits, including ultra high recovery and low chemical consumption. So if we take a closer look at the BioCleanse themselves, these are the encapsulated bacteria, which are selected either for nitrate or ammonia removal, are held within the porous matrix, and this allows the substrates to easily pass through, and this also results in high activity rates, very low to no organism losses, and very low waste sludge production. The gel carrier looks a bit like a contact lens, about 5 mm in diameter, and has a very high surface area. The unique aspect of the technology is the ability to maintain very high efficiency rates in saline conditions. So that's important for considering high strength brines, such as those used in ion exchange regeneration, where standard free cell bacteria cannot easily function. There's a few nice close-ups here of what they look like under SEM imaging. So you can see the porous, permeable sponge-like structure. And this is carefully controlled during manufacture to provide a suitable home for these bacterial biological communities to thrive and live. We manufacture these lenses now in a facility in China, producing around 40 tons of these per year. And we've already got a number of users in that region as well. So if we look into a bit more detail into what nitrification is and denitrification. So denitrification is the process of converting nitrate to nitrogen gas. With the bioclens bacteria, this occurs in anoxic conditions when oxygen levels are low and nitrate becomes the primary substrate. So when bacteria break apart the nitrate, it's first reduced to nitrite, NO2, and then in turn into nitrogen gas. A carbon source or organic substrate is typically used within the reaction, such as acetate or methanol. If there are simple chain organics present in the water already, they can also be used as the food source. So this is typically what the reactor will look like that houses these bioclens. In the binex process, this is where we couple that bioclens with the continuous ion exchange circuit, which allows us to reach less than 1 ppm consistently. The unique countercurrent movement of the resin that we have in our continuous ion exchange process ensures there's minimal effects of fouling, which can be a limiting factor for batch ion exchange and RO processes where bacteria and sludge are present. The bioclens treated brine coming off this is then filtered with a very small amount of purge, typically less than 1% of the flow. In most cases, that waste purge can actually be recycled up front. If there's an existing wastewater treatment plant, it can go straight up the front, or we can potentially blend that with some of the product. And then we can actually achieve a zero liquid discharge result. Salt usage is also minimized. We have a very small amount of top up, since the majority of the brine, over 99% of it, is recycled. So we just keep moving this circuit around, adding nitrate from the exchange with what we typically exchange chloride on the resin using salt, and then that nitrate comes into the bioclens reactor and forms nitrogen gas. Further research and development we've done in this space has enabled us to develop ultra-high specific nitrate resins, which does allow us to manage feed waters containing significant competing anions to nitrate in the water, such as waters with very high sulfate to nitrate ratios. So we can actually tune the CIF system to provide a unique sulfate desorption step. This allows us to have complete desorption of the resin and ensures that we can consistently reach these low nitrate levels of less than 1 ppm. So here's what a binex plant would typically look like. On the left, you can see a CIF system, which is our continuous resin system, which has a number of columns, typically with absorption, desorption, and wash steps. And we move the resin between the columns with airlifts. The bioclens system typically has 1 or 2 reactors in series and uses a specific mixing blade design, which is low shear. Other components of the plant typically includes process and chemical tanks, dosing systems, electrical and control to fully automate the plant. Flagship full-scale 12 megalitre per day plant is currently being constructed for a client in China on the back of some test work we've done. So that's due to be commissioned by the end of the year. We've also been doing a number of pilot trials, specifically one in Tianjin we've been doing for about 6 months to provide a proof of concept for a client who's struggling to reach a new set of low discharge limits that have been enforced on them, that they're currently being fined for because their system doesn't work. So our pilot treated up to about 100 cubes a day with a skid-mounted continuous ion exchange plant, you can see on the left, and 2 stages of bioreactors with about 10% loading of the BioCleanse denitrifiers installed in each. The inside of the reactor, you can see in the video on the right, you can actually see that the bacteria in the lenses go brown. This isn't sludge, this is actually what happens to the bacteria when they're operating at very high levels of removal efficiency. We also use a proprietary self-cleaning screen to keep the bio lenses within the reactor and allow the treated water to pass through. So over the pilot, which we did for about 6 months in total, we were consistently removing nitrate from about 20 ppm coming in to less than 1 ppm, typically undetectable. This actually resulted in a brine, which was desorbed off the resin, containing about 200 ppm of nitrate, and that was fed to the BioCleanse reactors. So after a few days of warming up, those bacteria eventually managed to reduce that 200 ppm down to typically less than 10 ppm, which is more than sufficient for us to have full regeneration of the loaded resin as it's returned to the continuous ion exchange system. We were able to optimize the 2-stage system that we had by reducing the carbon to nitrate dosing rate. You can see here we had a step change where we reduced it a little bit too much, and then we got it just about right. So this green line is the final discharge nitrate, and eventually with an optimized carbon to nitrate dosing rate, we were able to consistently be under 10 ppm. And then the activity rates of these bacterial colonies we can actually look at in terms of milligrams of nitrate removed per kilogram of lenses. And we were typically finding that we could get peaks of around 1,000, which is very, very high compared to conventional technologies. It just shows the high level of process intensification achieved with these encapsulated bacteria. And we've actually seen a lot higher rates than that as well in other example projects where we've only used about 2% loading, and the activity rates can be up to 5 times as much as this. So just to conclude, our encapsulated bacteria technology, which we've coupled together with ion exchange in our binex process, we believe is going to provide a fundamental shift in how bacteria and resins is applied to water treatment. They're going to be readily employed in the secondary and tertiary wastewater treatment spaces to provide both nitrate and ammonia removal to very low levels. So this is going to be a key enabler for recycled water reuse and also discharge compliance. Cost of treatments are very low, typically less than 10 cents per cube treated, and generates significantly less waste, or zero waste in some cases, where it's possible to recycle those streams. And future developments to look out for are where we're going to be potentially integrating the nitrate removal step with phosphate removal as well, using doped resins. And potentially that can also allow us to recover a solid reusable phosphorus product. So yeah, we're not done here yet. We're continuing to develop this further and excited to see where it goes. So thank you very much for listening, and hope to take any questions, or if we've got time. If not, then I would like to wish all the finalists involved good luck.
Okay, that was a pre-recorded presentation from Cleantech Water, so please don't send in your questions. But look, congratulations to everyone at Cleantech Water, winner of the IChemE 2021 Outstanding Achievement in Chemical and Process Engineering Award. Don't forget, all of this year's IChemE Global Awards webinars will be available to view on the IChemE YouTube channel very shortly. I'd also like to thank our sponsors, Baker Hicks, Johnson Matthey, PM Group, Sellafield Limited, and of course the Chemical Engineer. A big thank you also to the IChemE President, Jane Cutler, for joining us. Our 2022 awards open for entries early next year, so please keep an eye on the IChemE website and TCE magazine for more details. But until then, thank you for being with us and goodbye.